Am I audible? Hello? Hi, good evening. I hope my screen is visible. We will wait for a few more minutes and we will start. Okay. If you're able to hear me, please confirm that. Yeah, thank you. So we will wait for 2 more minutes and we will start. So today, basically, I will do some questions related with information theory as I have put in the website. So, but before that, I want to do one or two questions related with matrices. So these are one of the question that you can see. This is fairly simple and straightforward. One other question that somebody asked in the previous class, that is not very necessary. That's a very old question from 2004 GATE exam. But since one of you have asked that, I have done that. So I will just go through the solution. I think such questions have never been asked afterwards. Maybe in the last 10 or 12 years such questions are never asked. Okay, so if the one who asked that question is not joining, then I won't discuss that here because that's not very important. Anyway, the GATE exam is coming in this weekend, right? So we will do few questions very quickly. Okay. Okay. Since only two people have joined, we will make it more interactive. So I hope you can see the question. If you know the answer, you can just type in the chat window. Otherwise, I can explain. If you need me to explain this, I can explain. Okay, I think more people are joining now. Okay, so the first question is as follows. Let m power 4 is equal to I, where I is the identity matrix. Okay, I is the identity matrix, maybe of size n or something, and assume. So 1, 1, 1, 1 will come as diagonal entries, all the other entries will be zeros. So this is an identity matrix. It is told that a matrix M has m power 4. The fourth power of the matrix M is identity matrix. And also given that m square and m cube, they are not equal to identity matrix. Then for any natural number k, m inverse equals to. Okay. So first of all, what is an inverse of a matrix A? Suppose A is a matrix which is obviously a square matrix, maybe of size n by n. If A is invertible, then determinant of A will be not equal to 0. Or in other words, if determinant of A not equal to 0, A will be invertible. Okay. Yeah. So yeah, the answer that you have typed in the chat window is correct. Okay. Anyway, I will explain this very quickly. So suppose A is an n by n matrix which is invertible, we assume that. Then if I can find a matrix B such that A into B equal to B into A equal to I, then B is the inverse of A, or A is the inverse of B. Okay. So this is the definition of inverse of a matrix. Then now in the question it is told that m power 4 equal to I. Then for any natural number k, m inverse equals to. So m power 4 equal to I means m cube into m, that is m power 4, right, which is equal to I. Or m into m cube, which is also m power 4, which is also equal to I. That means m, if you compare this and this, m inverse is nothing but m cube. Okay, that is very straightforward. Now coming into the options, so the options are like this: m power 4k plus 1, 4k plus 2, 4k plus 3, and 4k. So you can readily see that the answer is C, but I will make you convinced that this is in fact for any k, m power 4k plus 3 is an inverse of the matrix M. So how does that happen? So m power 4 equal to I, which means that m power 4 power some k equal to I power k. So identity matrix power any integer is nothing but identity matrix itself. So m power 4k is equal to identity matrix. So m power 4k into m power 4, which is again identity matrix, equal to identity into identity, which is equal to identity matrix. So this can be written as m power 4k plus 4 or m power 4k plus 3 into m, which is equal to I. Or in other words, m into m power 4k plus 3 equal to I. So m inverse equal to m power 4k plus 3 for any integer k. So far so good. So the answer to the question is option C. So now we will see questions as per the schedules, questions related with information theory. Okay. So these are pretty straightforward questions. So in the recent past, all the questions that have been asked from the information theory related topic are fairly straightforward. So for that, one equation that you have to keep in your back of the mind is nothing but the expression that I'm going to write here. So what is this expression? That also you need to know. Okay. H of x equal to summation I equal to 1 to k pi log 1 by pi. This is nothing but the entropy of a random variable capital X. Entropy of a random variable capital X. So what is X? X is a random variable, okay, which has a probability mass function P1, P2 up to P capital K. So here you need to note one very important thing, that the h of x, the entropy of the random variable, depends only on the probability mass function. This is the probability mass function. Not depend upon the values that the random variable takes. For example, suppose I have a dice of 6 faces, okay, then it can have 6 possible outcomes, right? 1, 2, 3, 5, 4, 5, 6. So assume that this is uniformly distributed, the die is an unbiased die. In that case, the PMF will be nothing but 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. Correct? Each phase will occur with probability 1 by 6. Correct? Suppose I have some other experiment, okay, which has 6 possible outcomes. Say, instead of writing 1, 2, 3, 4, 5, 6 on the faces of the die, I am writing something else. Say I am writing A, B, C, D, E, F. And assume that that die is also unbiased. So the PMF, the probability mass function, will remain the same: 1 by 6, 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 1 by 6. Okay. So in both these cases, the entropy or the uncertainty associated with a random variable will remain the same. Okay. It does not depend upon these values, the values that the random variable takes, whether it is 1, 2, 3, 4, 5, 6 or A, B, C, D, E, F. It doesn't matter. The entropy from expression also, you can see it depends only on the probability mass function of the random variable. Okay, that is very important. Then one other property regarding entropy is that h of x will be less than or equal to log cardinality of this set. Okay, cardinality of this set. So in general, it is k. Correct. Suppose x can take values from the set x1, x2 up to say x capital K with a probability mass function p1, p2 up to p capital K. Then h of x will be bounded by log k bits. So whenever you are writing log in communication term, like theory, we will use base of the logarithm to be equal to 2. So then the unit of entropy will be bits. Okay. So these are the fairly simple ideas that you have to keep while you're going for gate exam. Now come to the question. This entropy has a lot of physical meanings. So this question basically it's a fairly straightforward one, but you need to understand that the question that is asked for is to find out the entropy of a random variable. Okay, the question is as follows. A discrete memoryless source has an alphabet A1, A2, A3, A4 with corresponding probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 8. See, a source that continuously emits alphabets. Okay, so the alphabet will be one out of these four: A1, A2, A3, A4. And the probabilities associated with these alphabets are nothing but 1 by 2, 1 by 4, 1 by 8, 1 by 8. So this is nothing but the PMF, probability mass function of the source, okay, or the source alphabets. So now the question is the minimum required average code word length in bits to represent this source for error-free reconstruction. So this may sound very unfamiliar, but this is in fact the physical definition of entropy. Basically, if you want to represent a source, okay, so entropy is nothing but the minimum required average code word length in bits to represent a particular source. Obviously, for error-free reconstruction. So this is nothing but the physical definition of h of x. So basically, entropy has significance in two particular cases. One is in source compression. Okay, that is this definition, and one other definition you will see later. Okay, so entropy is the minimum required average code word length to represent a source for error-free reconstruction. So now you have this equation to find out the entropy. You directly apply that. That's it. Okay, you can directly apply this equation and you can find the entropy. So there is nothing fancy in this. You just need to find out the entropy of the source. So here the PMF is nothing but 1 by 2, 1 by 4, 1 by 8, 1 by 8. So h of x, or the required answer, is nothing but 1 by 2 log 2 plus 1 by 4 log 4 plus 1 by 8 log 8 plus 1 by 8 log 8. So all the logarithms are of base 2. So now you will get, so log 1, 1 by 2, log 4 is 2, so 2 by 4. But 1 plus 3 by 4, which is equal to 1.75 bits. So the answer to the question is 1.75 bits. Is there any questions? Any questions or any doubts? Okay, then let us see one more question regarding this same idea. Yeah. So here, yeah, they have directly asked to find out the entropy of the source. Consider a discrete memoryless source with alphabet S0, S1, S2, S3, S4 up to infinity. In the previous case, we have seen that the source emits only 4 alphabets. So in the previous case, we have seen the source emits only 4 alphabets. Now the source can emit infinite number of alphabets, and the probability mass function is given. It's an infinite length vector, 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, dot, 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 dot. So this infinite series will sum up to 1 because it's a probability mass function. Okay, so now it is asked to find out the entropy of the source. Here they have asked directly to find out the entropy. In the previous question, the question was in fact indirectly asking to find out the entropy of the source. So there, the definition of entropy has given minimum required average code word length to represent a source for error instruction. Now they have directly asked to find out the entropy. But here the catch is to find out the entropy. There will be an infinite sum involved. So here the trick is to calculate that sum. Okay, let us directly do that. H of x, the entropy of the source equal to summation pi log 1 by pi. So I can write it as 1 by 2 log 2 plus 1 by 4 log 4 plus 1 by 8 log 8 dot dot dot. So this is equal to 1 by 2. Log 2 is 1. Log 4 is what? 2. 2 by 4. Log 8 to the base 2 is 3. 3 by 8. So next you will get 4 by 16. 5 by 32. This is a sum. Sorry, not a comma. Sum. So you need to basically find out this sum. So how do we find out that? This is, there is a trick. Most of you may be knowing that, but still I will do that. 1 by 2. So this 1 by 4, sorry, the 2 by 4 I will split into 1 by 4, again 1 by 4. So now 1 by 4 plus 1 by 4 is 2 by 4. So this 3 by 8 I will split into 1 by 8, 1 by 8, 1 by 8. 4 by 16 I will split into 1 by 16, 1 by 16, 1 by 16, 1 by 16. Okay, so on and so forth. So it goes like that. Now you may think that I'm overcomplicating things, right? Previously I had only one infinite sum. Now I have infinite number of infinite sums. But now you can easily calculate the sum of each of these rows. Basically all these are geometric progression which is of length infinity, or infinite geometric progression which has a sum which is equal to a divided by 1 minus r, where a is the first term and r is the common ratio. So consider the first row. First row means this row. Here the first term is nothing but 1 by 2. Common ratio is again 1 by 2, right? 1 by 2 into 1 by 2 is 1 by 4. 1 by 4 into 1 by 2 is 1 by 8. 1 by 8 into 1 by 2 is 1 by 16. Correct? So 1 minus 1 by 2. So which is equal to 1 by 2 divided by 1 by 2, which is equal to 1. Okay. So now consider the second row, which also has a common ratio which is equal to 1 by 2. But the first term is 1 by 4. So the sum I will write here. This is 1. Okay. So next, this sum has a sum 1 by 4 divided by 1 minus 1 by 2, which is equal to half. So this has a sum half. Again, if you find the sum of this infinite geometric progression, you will get it is equal to 1 by 4. This infinite progression, you will get 1 by 8. So it goes like that. Now you got a vertical sum to be taken, correct? Here, if you see, this is again a geometric progression which has a first term which is equal to 1 and common ratio again equal to half. So now the total sum equal to a divided by 1 minus r. A is the first term which is equal to 1 divided by 1 minus r. R is nothing but half. So this is equal to 1 divided by half, which is equal to 2. So the answer to the question, or the entropy of the source, is nothing but 2 bits. Is it clear? Any questions? Any questions? Clear? Okay, good. So now I will go to the next question then. Yeah. Now, this is one interesting question. Okay. So, a binary communication system makes use of the symbols 0 and 1. There are channel errors. Consider the following events. X0 corresponds to a 0 is transmitted. X1 corresponds to a 1 is transmitted. Y0 corresponds to a 0 is received. Y1 corresponds to a 1 is received. Okay. So the following probabilities are given. Basically, we can assume a channel here like this. So the channel can have inputs either 0 or 1, and output can also be either 0 or 1. Okay. So the following probabilities are given. Probability of x0 equal to half. That means with probability half, the transmitted symbol will be 0. Then with the remaining probability 1 minus half, which is equal to half again, the transmitted bit will be 1. Or in other words, probability of x1 is also half. Correct? So now it is given that probability of y0 given x0 is 3 by 4. What does that mean? Given the fact that 0 is transmitted, the probability of receiving 0, that means y0, is 3 by 4. So this transition has a probability 3 by 4. If I transmit 0 with probability 3 by 4, that received symbol will be 0. Then with the remaining probability 1 minus 3 by 4, that means with probability 1 by 4, the received symbol will be 1. Isn't it? Agree? Now, probability of y0 given x1 is half. That means if I transmit 1 with probability half, the received symbol will be 0. Correct? Y0. Given the fact that x1 is 1 is transmitted. So here the probability is half. Here also the probability is half. 1 minus half is again half. Correct? Now the question is the information in bits that you obtain when you learn which symbol has been received, while you know that a 0 has been transmitted. So again, it's a numerical answer type question. It's a question related with information theory. It is in fact a question to find out entropy of something. Okay. So now let us first of all see the definition of what is information means. Okay. So basically it is asked to find out the information in bits that you obtain when you learn which symbol has been received. So previously when I told about entropy, I told you that entropy is nothing but measuring the uncertainty in a random variable, right? How uncertain the output is, or how uncertain is the outcome is of an experiment. For example, maybe throwing a die. So there is an uncertainty associated with that, correct? So here the question is to find out the information in bits that you obtain when you learn which symbol has been received. Okay, there are two possibilities for receiving. It can be either 0 or 1. So it is already known that a 0 has been transmitted. So if I transmit 0, then the received bit can be either 0 or 1. Correct? With probability mass function 3 by 4, 1 by 4. Agree? So basically information is nothing but the reduction in uncertainty. So when you come to know, when you learn which symbol has been received, after that there is no uncertainty remaining, right? Because when I receive 0, I know that 0 is received. So there is no confusion in that. But when I transmit 0, before receiving something, there will be a confusion. The received bit can be either 0 or 1. So that reduction in confusion or reduction in uncertainty is nothing but the information. So here the information is nothing but the initial uncertainty before receiving 0 or 1. Basically, if I transmit 0, there are two possibilities in the receiver side. The receiver can receive either bit 0 or bit 1 with probabilities 3 by 4 and 1 by 4 respectively. Okay, so when I receive, it can be either 0 or 1, but when I receive one bit, I will know which one is received, right? It can be either 0 or 1, but once I receive a bit, there is no uncertainty. It is already known. So the information that is obtained is nothing but the initial uncertainty. That is nothing but the entropy of a random variable having this probability mass function 3 by 4 comma 1 by 4. So the information is nothing but, so I will denote that with I, which is equal to 3 by 4 log 4 by 3 plus 1 by 4 log 4. So you can calculate this if you want. I can calculate. Okay, so is it clear? First of all, if you have some questions, you can ask. Any questions? Is it clear? So this is nothing but 0.311 plus half, right? So log 4 is 2, 2 by 4 is 0.5. So the answer is nothing but 0.811 bits. Any questions? Is it clear or not clear? Clear? Great. Okay, then we will move to the one last question. By that, we will wind up. This is slightly lengthy question. Basically, it's a conceptual kind of question. Okay, so I have solved this question in the previous phase, but anyway, I will solve it once again. So a channel is given here and it is asked to determine. So basically, the channel is represented here with these probabilities, as you have seen in the previous case. These four probabilities will determine a channel. Okay. So here I can say probability of y equal to 0 given x equal to 0 is nothing but 0.25. That means if I transmit 0 with probability 0.25, a 0 will be received. Now this probability is nothing but when, sorry, x equal to 0. Let us first see that. Okay, so what is this probability? That means when the channel input is 0 with probability 0.75, the output will be 1. So this is nothing but 0.75. Now probability of y equal to 0 given x equal to 1. That means when I transmit 1, then with probability 0.25, a 0 will be received. So this is equal to 0.25. Finally, what is this probability? This is nothing but this probability. When I transmit 1, then the received bit will be 1 with probability 0.75. So here, four options are given. The channel is a lossless channel, a noiseless channel, a useless channel, a deterministic channel. Any idea what is the answer? Maybe useless. Okay. Okay, anyway, I will come to the answer. Okay. I will see what are the definitions of these channels. Okay, lossless channel, noiseless channel, useless channel, and deterministic channel. So first we will see what is a lossless channel. So the definition, the information theoretic definition is this: h of x given y equal to 0. Okay, I already told that x denotes the entropy. Entropy means uncertainty. H of x given y means, so I'm denoting the input of the channel with x, random variable x, and output of the channel with random variable capital Y. Okay, so h of x given y equal to 0 means when the output is given, when y is given, there is no uncertainty in the input. That means when I receive something in the something at the output, it is clear that what has been transmitted from the transmitter side. So that is the physical meaning of this information theoretic definition, h of x given y equal to 0. For example, if I have a channel like this, okay, so the channel input can be either A or B, output can be either X, Y, or Z. Is this lossless? So I have some probability. Say if I transmit A with probability 0.4, the output will be X. With probability 0.6, the output will be Y. Hello, are you able
Hello.
to hear
Yes,
me?
sir. Yes, sir. Your voice is audible.
Okay, okay. Sorry for that. I think in between I lost my connection. Okay. Anyway, now you are able to see my screen, right? Yeah.
Yes,
So
sir.
yeah, great. So now, yeah, here in this case, if I receive X at the channel output, what is the input? The input will be definitely A, right? So if I transmit B from the input, the output can never be X, correct? So when I come to know the output, the input is already known. If I receive X, then definitely A is the transmitted symbol. If I receive Y, then also A is the transmitted symbol. If I receive Z, then definitely B is the transmitted one, correct? Is it clear? So in this case, when the channel is when the channel is lossless, you have to observe that the number of output symbols will be greater than or equal to number of input symbols. Okay, here there are two input possibilities, there are three output possibilities, right? So output, the number of outputs will be greater than or equal to number of inputs when the channel is lossless. Okay, now come to deterministic. Deterministic has a definition h of y given x equal to 0. Here something completely different from the lossless case. When x is known, that means when the input is known, the output is deterministic basically. If you fix the input, then the output is fixed. Okay, for example, I will make something like this. The input can be either A, B, or C. The output can be either X or Y. So here 1, 1, 1 probabilities. Because if I transmit A, then the output will be X with probability 1. That is the deterministic part. So if the channel is deterministic, all these transition probabilities will be 1. Okay. Also, you have to note one more thing. N of O will be less than or equal to N of I. That means the input symbols will be more compared to the output symbols in this case, or maybe equal. Correct? So again, I will make the definition clear. H of y given x equal to 0. That means when I, this given means if I know x, there is no uncertainty in Y, or there is no entropy means there is no uncertainty in the output. So in this case, if I know X, say if I say the input is A, then the output is X, right? There is no confusion. In the case of lossless, if I transmit A, there is a confusion in the output. It can be X or Y. But there is one difference in the lossless case. If I receive something, say if I receive X, there is no confusion in the input. It will be definitely A. But if you come to deterministic channel, if I receive X, in this example, we still have a confusion whether the transmitted symbol is A or B. But if you know the input, the output is fixed. I hope it is clear and you are able to distinguish lossless and deterministic channels. It should be fine, right? Correct? Yeah, great. And noiseless channel means a channel is noiseless if it is lossless and deterministic. What does that mean? Then there is only one possibility. This is that possibility. Say A, B, say I have three A, B, C, and X, Y, Z. 1, 1, 1. Number of output equal to number of input symbols. So now this is noiseless. Correct? So if I know the input, output is known. If I know the output, the input is known. Correct? So there is a one-to-one correspondence. That is what is meant by noiseless. I hope it is clear. So finally, so now from the, so if you look at the channel in the question, so if you see this channel, do you think it is lossless or noiseless or deterministic? Do you think so? Is it lossless first of all? Say if I receive 0, do I know which one is the transmitted bit? I don't know, right? It can be either 0 or 1. So it is not lossless. Is it deterministic? If I transmit 0, do I know which will be the output? It is also not known. If I transmit 0, the output can be 0 or 1. So it is not deterministic. So is it noiseless? Obviously not, because it is neither lossless nor deterministic. So it cannot be noiseless. So only remaining option is useless. So the answer to the question is, as you have rightly pointed out previously, the answer is the channel is a useless channel. Okay, so now we will see the definition of a useless channel. Useless channel means the mutual information between the input and the output is equal to 0. Or in other words, mutual information I of x, y can be written as h of x minus h of x given y. Okay, or in other words, you can write it as h of y minus h of y given x. So how can you determine a channel is noiseless? That is very simple. You can in fact make a this transition probability matrix. Okay, so 0, 1, 0, 1. So basically this corresponds to input and this corresponds to output. If I transmit 0, then with probability 0.25, the output will be 0. Similarly, if I transmit 0, the output will be 0.1 with probability 0.75. Agree? Similarly, if I transmit 1, the output will be 0 with probability 0.25 and 1 with probability 0.75. Correct? So in a channel transition matrix, if there are identical rows, okay, then the channel is useless. Do you agree? So if you want, I can calculate I of xy and I can show you I of xy equal to 0 in this case, but that is in fact not needed. The channel is useless or not. If there are identical rows in the channel transition matrix, then the channel is useless. Is it okay? Not okay? Is it clear? Yeah, great. So today I do not have more questions. If you have some questions that I should discuss, I can discuss now. Okay, I have finished all 5 or 6 questions. I have in fact prepared 6 questions, but one question is it's an obsolete one. It's from 2004. This is that question. I think nowadays these kind of questions are not being asked in the GATE exam. This question involve a lot of theory, including similarity transform, diagonalization of a matrix. I think those things are not part of GATE syllabus nowadays. But some of you have asked to solve this in the last class. That's why I just prepared the answer. You can just go through that. But if you have any other question that we should discuss, then we can discuss now. We have plenty of time, around 20 more minutes remaining. Or some questions that we have discussed in the previous sessions or something. So I do not want to like inject a lot of theories because this is the last week before the GATE exam, right? But if you want to discuss some specific questions or some specific things that we have discussed in the previous classes, I can refresh those things. I can just go through those things. Anything? You can just unmute and talk. Only very few people are there in the meeting. Or if you want to know something specific, you can ask that. Or maybe just scroll through the last year question paper 2022. That's also fine. But I may not be able to answer all of them. Obviously, there will be questions from wide variety of topics, right? So we can do anything around 17, 16 minutes, 16, 17 minutes remaining. It's all only 6:43, 44. So one of you can unmute and talk. Only 3 people are there in the meeting now. 4 people, in fact. Anybody? Any questions or any doubts? Nothing? Anything. So if not, I can maybe go through previous week's questions, some questions from DFTs, some linear algebra questions, maybe from random process, anything.
Sir, can you please just go through DFT questions?
Last week questions, sir.
Yeah. Any questions, sir? Like you have discussed DFT in previous weeks now.
Yeah, I will take that. I don't remember in which class. Hold for a second. Yeah. Okay. Yeah. Are you able to see this?
Yes, sir.
So here, so you can see all the answers, everything, but I can just go through that again. Say I have a vector x, so x0, x1 up to x7, which has a length 8, okay, and it has a DFT which is denoted with capital X. And in the question itself, it's a very recent question from 2022. The formula to find out DFT is already given, and also a vector is given 1 0 0 0 2 0 0 0. And the question, the interesting part is to find out DFT of DFT of this vector. And you do not need to find the entire DFT, you just need to find out y0. That means the first element in that. Okay. So anyway, I'm not going through the solution. We will solve it very quickly. So the vector given is nothing but 1 0 0 0 2 0 0 0. Correct? Yeah. So x of k is given as summation n equal to 0 to 7 x of n e power minus j 2 pi n into k divided by 8. Correct? So now you have to find out. So basically DFT of this is x, vector x. DFT of x is a vector which is of length 8, x0, x1 up to x7, correct? 8 length vector. So again, you have to take the DFT of this vector, whatever you're getting, the DFT of this vector, that is this DFT of x. I will denote that with capital X. Again, you need to get a new vector, DFT of capital X, which is equal to some other vector y. And so this will be some y0, y1 up to y7. Again, an 8 length vector. And it is asked to find out y0. So question is very straightforward and the solution is also not very difficult. Okay. So yeah, let us come to the question. So if you see x, there so only two non-zero entries in this small x, correct? X0 is 1, x1 is 0, x2 is 0, x3 is 0, and finally x4 is nothing but what? X4 is 2. Again, x5 is 0, x6 is 0, x7 is also 0. Correct? Now, x of k, I will write it here. Zoom out. X of k is equal to. So in this summation, I have only two non-zero entries. The first one is corresponds to x n equal to 0. x0 into e power, so n equal to 0, e power 0 plus x of 4 into e power minus j 2 pi n equal to 4 into k divided by 8. So which is equal to x0 plus x4 into e power. So this 4, 2, 8 are gone minus pi j pi k. Correct? What is e power j pi or minus j pi? So e power j pi is equal to minus j pi equal to cos minus pi plus j sine minus pi, which is equal to, what is this value? This is nothing but minus 1, correct? Sine pi is 0. So x of k equal to x of 0 plus x of 4 into minus 1 power k. Agree? Or in other words, x of 0 is 1 and x of 4 is 2. So 1 plus minus 1 power k into 2. That means this vector x equal to this vector, this is equal to, so if I substitute k equal to 0, I will get minus 1 power 0, which is equal to 1. So this is 3. And the next one is, if I put k equal to 1, I will get minus 1 power 1, which is equal to minus 1. So minus 1 into 2 is minus 2. 1 minus 2 is nothing but minus 1. Again, you will get 3 minus 1, 3 minus 1, 3 minus 1. Right? So far, so good. Is there any question? Is it clear up to this point?
Yes,
Okay.
sir, it's clear.
Yeah, great. So now you need to find y. In fact, you do not need to find y, you just need to find y0, correct? So how do you find y0? That is nothing but k equal to 1 to 7 x of k e power minus j 2 pi. So n should be 0 here because it's 0 into k divided by 8. Correct? Which is equal to summation k equal to 1 to 7 x of k. So you just need to take the sum of all these. So 3 plus 3 plus 3 plus 3 4 times. So 12, and 4 minus 1s are there, minus 4. So 12 minus 4, which is equal to 8. So y of 0 equal to 8. So the answer to the question is nothing but 8. I think that was the answer when we did last time as well. Yeah, correct. It was 8. Now also it's 8. Is it clear? Any questions regarding this question? I hope it is clear. So should I do one more question related with DFT? Which question do you want? This one. This is quite complicated one, but anyway, let us do this. This is again something of the same sort, DFT of X. Okay. Now we are, so previously we were seeing n equal to 8. Now we will see 4 length sequences. And the question is to find out an X such that DFT of X equal to X. Correct? So here you need to use two things. So I can go through the, I will do it afresh. Okay. So what happened? Yeah. So the question, so now what is the definition of DFT? X of k equal to summation n equal to 0 to 3 x of n e power minus j 2 pi n into k divided by 4. Correct? And this is DFT. And what is IDFT? The inverse DFT. So here I think in the question the definition is given with the 1 by root and outside. Yeah. So that you have to be very careful. In the question it is defined like this. So we also need to define in the same way. So this 1 by root n, that means 1 by 4 in this case. Sorry, 1 by root 4. So 1 by 2 will come outside. So this IDFT will also have a similar 1 by 2 outside, 1 by root and outside. Summation k equal to 0 to 3 x of k e power j 2 pi n k divided by 4. Clear? So this is the definition of DFT, IDFT, this 1 by root n, or in this case it is 1 by 2, that usually accommodate in different ways. Sometimes we will, in the forward DFT, we will take nothing outside the summation, we will take just 1. And when you are taking IDFT, we will take 1 by n. Okay, but in the question, it is defined in this way, 1 by root n in forward and reverse DFTs. That means in DFT and inverse DFT. Okay, so accordingly, this energy relation, Parseval's theorem, everything will change if you adjust this 1 by root n. But anyway, we will stick to the question. For solving this question, this 1 by root n has to be outside because we are taking DFTs consecutively 2 times. So otherwise, yeah. So we need to find an X such that DFT of X equal to X. So that means if you take DFT twice, you will still end up with the same X. So you know one thing, right? X, this is true always. DFT of X is always X because inverse DFT is the inverse of the DFT operation. Correct? So this is always true. This statement is always true. Agree? Do you agree with that? Yeah. So now what should be done? So here we know this fact, but out of the 4 options given, we need to determine which X will satisfy this relation. So here it is not IDFT, here it is DFT. So now let us write the IDFT equation X of n equal to 1 by root n or 1 by 2 summation k. I will write it as 1 by root n itself. So I will first I will make a general thing, k equal to 0 to n minus 1, okay, x of k into e power minus j 2 pi n into k divided by capital N, right? This is the IDFT equation. Okay. So here, if you see, what is the difference between this and the DFT equation? Nothing but there is a minus here. Sorry, here there is no minus. The minus will come only in the DFT. Sorry for that. So, correct? So here it has to be plus in the inverse DFT equation. This is IDFT equation. So now what will I do? If I do this x of minus n, I can write like this, right? 1 by root n, k equal to 0 to n minus 1, x of k e power minus j 2 pi into minus n into k divided by capital N. Is it okay? Can I write like this? Because wherever I have n, I am replacing n with minus n. Nothing is changing in this case, right? Is it clear? Yeah, good. So now can you tell something from observing this? And basically you need to see the these options. So there are already answer is also marked. So so here if you see, I have written in the previous class. So now come to n equal to 4, capital N equal to 4. Then, so first of all, what is minus n? X of minus n is nothing but, I can write it as, so x of the vector x is equal to x0, x1, x2, and x3. Now, what is the sequence? X bar of minus n or x of minus n. What is that sequence? That sequence is nothing but, say I will call it as some y, which is equal to, so minus of 0 is nothing but 0 itself, correct? Now, what is x of minus 1? X of minus 1 is nothing but x of minus 1 plus n. N is the period of that DFT. So here it is 4, which is equal to x of 3, correct? So x of 3, x of minus 2 is nothing but x of minus 2 plus 4, which is equal to x of 2. X of minus 3 is nothing but x of 1. So this will be ideally the DFT of, sorry, DFT of x will be y. So DFT of x will have this form: x0, x of 3, x of 2, x of 1. Do you agree? Is it clear? So if I take the DFT of x once and if I again take DFT, I will end up with this. So there is a permutation happened in the vector. That's the only difference. Is it clear? Any questions? Is it clear or not? Yeah, it is clear. Now, so in the question, it is told that DFT of x should be equal to x. Or in other words, in this case, vector x should be equal to vector y. For that, x0 will be anyway equal to x0. This should be equal, x1 equal to x3 and x3 equal to 1. That is same, x3 equal to x1 and x1 equal to x3. So in whichever vector x1 is equal to x3, then that vector will have this property. DFT of x equal to x, correct? So you need to see x of 1 and x of 3, correct? X of 1 and x of 3. If it is equal, if those two terms are equal, then DFT of that vector will be the same vector. So in this case, 2, 4, they are unequal. Here it is 3, 2, they are unequal. Here it is 2, 2, they are equal. So this is the answer. And here again 2, 3, they are different, correct? So the answer to the question is option B. Is it clear? Yeah. So now it's exactly 7 o'clock. If you have a few more questions, I can do it. If not, uh, best wishes for everyone for the coming GATE exam. So write the exam with full of confidence, and all of you will be able to crack the GATE exam with uh, uh, colorful marks. How to prepare for last 4 days? Okay, that's actually so what you can do is that you can. So I hope all of you may be practicing or maybe preparing for the exam for last few months. So you may be having short notes and everything. You can go through these equations like what we have seen today, entropy equation, maybe some equations, maybe in communication one very useful equation will be this, right? Capacity related equation, which is nothing but Mm, capacity of a channel is nothing but B log 1 plus SNR. So these kind of equations you will be having that you can go through, and especially like from topics like EMFT, field theory, correct? Electromagnetic field theory. There are a lot of equations. So you can just go through those equations, and also uh, try not to learn very new topics in the coming 4 days. Like small extensions of whatever you are knowing is absolutely fine, but don't take and start studying a completely new topic that you are not very comfortable with. That will waste your time and that will lose your confidence. So the first and foremost thing that, like, even if you know everything, you have to perform well in the exam, in the GATE exam. It's a 3 hour process, right? You have to have that presence of mind during the exam. So the first question that you're looking, that you may not be able to solve, you may or may not be able to solve. So that depends on what you are very comfortable with, right? So if you are not able to solve the first question, don't lose the confidence. Go to the second question. Don't waste on questions that you do not know the topic very well, or if you are not very comfortable with something, you can like attempt the question if there are no negative marks, but don't waste too much time on some particular questions. Okay, so easier questions will be awaiting at the end. That if you miss that, you will miss mark. So similarly, before the exam for the next 3 or 4 days, like try to like keep fresh. You yourself be very fresh in the sense that don't study something completely new now. So sometimes you may not be able to understand things that will like that will affect your moral and your confidence, everything. So that is one thing. And regarding the preparation, coming to the preparation of this exam, don't try too much for the next 3 4 days, but whatever you know, you be comfortable with that. Go through whatever you have studied till now, or if you want to focus on some particular questions, if you feel that that question is important, then you see that. Okay, and also you can go through last year question paper, and you can just see the pattern, and you can like give more emphasis on something that are being asked recently, maybe for past few years. Some topics may be having more focus on, so such topics you can spend more time maybe. And obviously go through all these equations. Some equations will be very necessary. I'm not able to recollect all of them. One such example I have written here, this the capacity of a Gaussian channel. And yeah, that's it. I think these 3 4 days is it's more for mental preparation rather than studying for the exam, and also consolidating everything that you have studied for last few months, maybe last 1 year or so. So try to recollect everything that you have studied. So you may not be remembering what you have studied exactly before 8 months or so, that you try to recollect. Okay, but try not to study something completely new. That will kill your time. That's it. And you will feel that you do not know something. That feeling should not be there when you're going for an exam. You have to be very confident. Okay, I don't want to preach like this. So if you have some specific questions, I can ask. Anyway, all the best for all of you. So I hope all of you will crack the GATE exam with lot of colors. Hopefully, we will see here maybe at IAC or maybe at some IITs. Okay, great. Best of luck. Thank you. Thank you, all of you, for joining the class. Thank you very much. Okay, so let us wind up. If you do not have any questions, we can wind up the session. Once again, best wishes for all of you.
Thank you so much, sir.
Thank you.